This presentation was made to the 2021 Grassland Society of Southern Australia annual conference and was based on a paper I completed for the Grassland Society that is available from the Red Sky website. The presentation is titled Changing Production Systems, Improving Profit in Australian Dairy. The subtitle is High Pasture Harvest is not enough for consistently high levels of profit. A high percentage of pasture in the diet is also required. My presentation will cover the following. Firstly, some background, and then I'll put the argument. I'll highlight some key trends in the Australian dairy industry, and then look at whether increasing milk revenue might be the answer. Next, I'll review whether pasture harvest is the problem, as well as reviewing why pasture harvest is important. Then I'll look at whether total feed cost is the answer, and how pasture as a percent of the cow's diet impacts on profit. I'll also review what else pasture might impact, and then summarise at the end. My presentation is predominantly informed from two papers that I had published in 2020 and a report I published this year. The first of these was based on country comparisons titled Evaluating the Loss of Profitability in Declining Milk Production in the Australian Dairy Industry. The second paper was titled Key Determinants of Profit for Pasture-Based Dairy Farms and included the analysis of a large unbiased database of Australian dairy business performance. The report included extensive analysis of 8 countries and every dairying region of Australia. This is a table of the data sources utilised, which are outlined in my paper. All these sources are arguably the most accurate and reputable sources of data for each region. As indicated in the left of this table, I've endeavoured to use some aspect of national or regional colours to represent each region in the graphs. So what is the argument? Well, the question is, how can profit be improved in Australian dairy? And the argument is that pasture harvest is usually accepted as important to profit on pasture-based dairy farms, but that the production system is not. That is, that pasture as a percent of the cow's diet is unimportant. First, some definitions. Pasture does not equal homegrown feed, but rather includes all pasture and other crops consumed by the cows in situ, as well as any pasture mechanically harvested on the dairy farm. And pasture-based refers to farms where cows consistently walk to paddocks and harvest the pasture themselves, with no minimum percentage level of pasture required, though practically this really falls below 25 to 30%. I appreciate my topic directly relates to the dairy industry. However, the principles I'll be talking about equally apply to any form of pasture-based livestock farming. This first graph outlines the changes in pasture as a percent of the cow's diet over the last 18 years for all regions in Australia plus New Zealand. Effectively, for over 20 years, there has been significant decreases in the percentage of pasture in the diet, with the one exception being Tasmania in dark green near top. New Zealand is the dashed black line at the very top, which is the standard bearer for maintaining a high percent of pasture in the diet. In all state and regional graphs, the average outcome for Australia is represented by a dashed brown line, with Western Australia in gold or yellow, whereas in international country comparisons, Australia is represented by a yellow line. This graph outlines the trend in cost of production per kilogram of milk solids over the same period, with all Australian regions losing considerable ground compared to New Zealand in dashed black. Of great concern is the number of regions that now have a similar cost of production to the US in dashed purple. New South Wales in light blue and Queensland in dark red have seen the greatest increases in cost of production, which now far exceeds that in the US. This graph of return on capital or profit helps to highlight the problem for Australia in yellow, with profit progressively moving to the bottom of the pack. In this first period, Australia has a similar or higher level of profit than New Zealand, as does Argentina in light blue and Uruguay in dark blue, both of which have also significantly decreased pasture as a percent of the diet over the last 15 to 20 years. By the end of the period, all three countries are consistently worse off than New Zealand. This graph plots growth in milk production using 2000 as a base of 1, with South Africa in dark green and New Zealand in black having the highest growth. Ireland in light green is not far behind, having had exceptional growth since quotas were removed. And like New Zealand farmers, Irish farmers maintain a high percent of pasture in the diet. Australia has the poorest growth, and it is the only country with negative growth across the 20-year period. It would not be logical to expect consistent growth in milk supply if farmers are largely unprofitable. The next two worst performers are Argentina and the UK, which are the two other countries that have had the greatest decrease in pasture as a percent of the diet after Australia. If we now look at all the states of Australia, with New Zealand and the US as dashed lines, then Tasmania is the only state that has consistently grown milk supply, with Queensland having contracted enormously and South Australia having contracted the next most. You should not assume Australia's poor performance is from a higher number of dairy farmers leaving the industry than is the case for other countries. Over a 40-year, 20-year or 10-year time frame through to 2020, the reduction in Australian farm numbers has been similar to many other countries, with some other countries having greater and others lesser rates of loss. The primary factor is that those farmers remaining in the industry in recent times in Australia have been growing the size of their farms at a much slower rate than in other countries, which again is what happens when too many farmers lack consistent levels of profitability. To summarize these trends, this graph represents the percent or the present levels of pasture as a percent of the diet, with the US at far left and New Zealand at far right, and all the Australian regions between these two. As you move from left to right, pasture percent of the diet increases and cost of production decreases. However, it is true that cost of production is not the be-all and end-all in regard to determining the levels of farm profitability. If milk revenue can be increased at a faster rate than comparative costs, then the optimal profit point for a dairy business will be at a higher level of cost of production. There are primarily two factors that impact on milk revenue: milk price and milk production. So what is the likelihood that milk price could increase significantly on a continuing basis in Australia? Most of the recent discussion within the Australian industry is related to milk price being too low and the need to increase this. Well, there is a big problem with this idea, as the milk price in Australia has been more than competitive with other countries over the last 20 years. This slide shows the average milk price in Australian dollars per kilogram of milk solids over the last 6 years, including the period when MG and Fonterra dropped the milk price late in the season. As you can see, Australian dairy farmers have been paid a very competitive price, especially against other Southern Hemisphere countries. This is effectively true for all of the last 20 years, as reported in one of my published papers. The US is shaded dark red or maroon in the country comparison graphs, and purple when included in the Australian regional graphs, so that Queensland can retain the maroon notation. The very high milk price for the UK has been heavily influenced by a period where the pound appreciated against the US dollar, though it would be reasonable to presume that the UK milk price would stabilise over time at a level much closer to the US and EU value. If we look at the regional variations in milk price over the same period, with New Zealand and the US included, you can again see that milk prices have been more than competitive with other countries. And for some regions, like New South Wales, Queensland, and Western Australia, milk prices have increased in these states by so much over the last 20 years compared to other countries that farmers already get paid a similar or higher milk price than that received by US farmers. So if a significant and continuing increase in milk price is most unlikely, how about an increase in milk revenue from higher production of milk per cow? Well, the first problem with this is that milk production per cow does not correlate with profit, or not substantially. This slide confirms the relationship from one of my published papers in 2020. This graph has milk production per cow and energy corrected litres on the horizontal axis and return on capital on the vertical axis. This relationship is different to that for feedlot or TMR dairy farms, where milk production per cow does positively correlate with profit. Though feedlot or TMR production systems do not offer a solution for Australian dairy farmers, as the cost of production on these farms is substantially higher than on pasture-based dairy farms. The second problem is that Australian dairy farmers have been increasing milk production per cow at a similar rate to other countries over the last 40 years, as this slide shows. If the time frame is shortened to the last 20 years, the picture is similar, even if a little less clear. So again, it seems illogical to contend that Australian farmers can expect to lift the rate of increase in milk production per cow compared to other competitive countries. And even if this were possible, it would not have a significant positive impact on profit. So it is reasonable to conclude that for all regions of Australia, decreasing cost of production rather than increasing milk revenue is the only reliable and sustainable option for increasing profitability on most dairy farms. Before exploring the impact of changes in pasture as a percent of the diet, let's review if changes in pasture harvest have been negatively impacting on profit. This slide compares the level of pasture harvest over the last 18 years in 5 countries and confirms pasture harvest has not been a factor in the cost of production and profit trends, with Australian dairy farmers having at least maintained, if not improved, their position compared to 3 or 4 of the other countries. And in fact, in the early period now highlighted, Australian farmers, as well as Argentinian and Uruguayan farmers, were more profitable than New Zealand farmers when the gap in pasture harvest compared to New Zealand was, if anything, greater. South Africa in dark green is the one outlier in this graph, and its substantial increase in pasture harvest over a 15-year period was based on significantly increasing the area under irrigation on many farms, plus a strong focus on improving pasture management. This slide outlines the changes in pasture harvest within each region of Australia, with New Zealand and Argentina included as dashed lines. Tasmania and Gippsland have made significant progress in increasing pasture harvest over the last 20 years, with these 2 regions having the highest pasture harvest, the highest percent of pasture in the cow's diet, and the lowest cost of production. Northern Victoria, New South Wales and Queensland have seen the largest decreases in pasture harvest, while also having the largest decrease in percent of pasture in the cow's diet and the greatest increase in cost of production. The decrease in pasture harvest in these states would at least partially be a result of decreasing pasture as a percent of the diet, as was reported in one of my papers published last year. This slide outlines how pasture harvest per hectare on the horizontal axis impacts on profit or return on capital on the vertical axis. This is a widely reported relationship and is widely accepted, though it is important to understand why increasing pasture harvest improves profit. What is the causal link? The cause is that the cost of pasture is comparatively low compared to any other feed source, and that high levels of pasture harvest per hectare most often result in a further lowering of the cost of pasture. In addition, a high pasture harvest per hectare will in all probability result in a higher number of cows being farmed per hectare and a higher volume of milk being produced per hectare. The comparatively low cost of pasture compared to any other feed source is illustrated in this table, which includes the average cost of pasture, concentrate and forage over the last 6 years for all regions in Australia and for 7 other countries. In the left-hand column is the average cost of pasture, ranging from a low of $56 per tonne dry matter in New Zealand to a high of $196 per tonne in New South Wales. All of the feed costs are consumed feed costs, so they include the production or purchase cost, as well as wastage and any storage cost. The next 2 columns include the cost of concentrate and the percentage increase in concentrate cost to pasture cost. The important factor here is that regardless of the cost of pasture, The cost to concentrate in every region is hugely higher than for pasture. The final two columns include the cost of forage and the percentage increase in forage cost to pasture cost. Although the percentage increase in forage cost to pasture is lower than for concentrate, it is still very significant for most regions. The degree of increase in concentrate cost is dramatic and will hopefully reinforce for you that the causal reason why pasture harvest correlates strongly with profit is that pasture is the lowest cost source of feed by a wide margin. And increasing pasture harvest per hectare allows more milk to be produced per hectare from this low cost feed. This next table should impress on you why decreasing the cost of feed almost certainly must be the major contributor to any future reduction in cost of production and improvement in profitability. The table includes the average level of total expenses per kilogram of milk solids over the last 6 years, with this split between the feed cost, labour cost, and all other costs, with these also calculated on a percentage basis of total feed expenses, total expenses. Total feed cost comprises 50 to 60% of total operational expenses for an Australian dairy business, with labour cost the only other major cost at less than half of this. So feed cost is both the dominant cost in dairying and importantly the most variable. So it almost certainly must be the primary target for reducing cost of production and improving profit. This can be further demonstrated in this slide where 8 countries are compared on total expenses per kilogram of milk solids, with the split between feed cost in green, labour cost in orange, and all other costs in blue. New Zealand and Ireland are the leading countries with low feed costs based on a high percent of pasture in the diet. Australia has progressively lost its position as a low-cost producer of milk, with many Australian farmers having a fascination with imitating the US feedlot industry. In the US, the cost of concentrates and high-quality forages are some of the lowest, if not the lowest in the world, while Australia has the highest cost of labour of any country. So when Australian farmers imitate this US system, then their total expenses will be in the order of this yellow column. This is a similar graph for all regions of Australia plus New Zealand and the US. New Zealand, Tasmania, and Gippsland have the lowest feed cost and the lowest total expenses per kilogram of milk solids, with Western Australia, New South Wales, and Queensland having the highest feed cost and similar or higher total expenses per kilogram than the US. Again, you should be able to visualize what will happen to both feed cost and cost of production as more and more New South Wales and Queensland farmers in particular adopt TMR and feedlot production systems. So how can farmers in any of the regions reduce feed cost? Well, there are only 2 options. Firstly, by significantly reducing the unit cost of feed, and secondly, by changing the mix of feeds to reduce the average cost. Although some individual farmers may be able to significantly reduce the unit cost of supplements, this would not appear possible for large groups of farmers, and not for one group of farmers in a region of Australia compared to other farmers in competing regions or countries. So the only realistic option for most Australian dairy farmers to significantly reduce their cost of production and increase their profit margin would be for these farmers to change the mix of feeds by including significantly more low-cost pasture and significantly less high-cost supplement. This option of changing the mix of feeds can be illustrated with this table, which includes the average cost of feed for Australia over 2015 to 2020. Across the top, there was a range of percentages of pasture in the diet from 0% to 80%. There are 2 calculations of pasture cost, one where the pasture cost is held constant for all options of pasture percent of the diet, and the second where pasture cost is more correctly lower when pasture is a higher percentage of the diet. These variations in pasture cost for different percentages of pasture in the diet are based on an analysis of a large unbiased Australian data set which was reported in one of the papers I had published last year. Next, there are the average costs of concentrate and forage, followed by an average supplement cost based on 70% concentrate and 30% forage. And finally, the calculated average feed cost, which you can see is hugely impacted as the percent of pasture in the diet decreases. If we compare the average cost of feed when moving from 70% pasture to 30% pasture, then this increases the average feed cost by over 50%, over 50%. The impact of feed costs per tonne dry matter on total feed cost per kilogram of milk solids is illustrated in this slide, with the columns representing the feed cost per tonne dry matter and the line and dots representing feed cost per kilogram of milk solids. All dairy regions of Australia are included, plus New Zealand. Although it appears self-evident that the average cost of feed per tonne dry matter would have a major impact on profitability, given feed costs comprise around 50 to 60% of total expenses, this can be further confirmed from the following slides. This graph has the consumed feed cost per tonne dry matter on the horizontal axis and total feed cost per energy corrected litre on the vertical axis. This confirms that the consumed feed cost per tonne dry matter could explain 70% of the variation in total feed cost per litre. This graph now has total feed cost per litre on the horizontal axis and total expenses per litre on the vertical axis. This confirms the total feed cost could explain 50% of the variation in total expenses. And this graph now has total expenses per litre on the horizontal axis and return on capital or profit on the vertical axis. This confirms that total expenses per litre could explain 51% of the variation in profit. These results reported in one of my published papers in 2020, with similar results reported in other published papers. So feed cost per tonne dry matter is a paramount factor in determining profit, and the only available option for significantly minimising feed cost per tonne is including a high percentage of low-cost pasture in the diet. This is further evidence that pasture as a percent of the cow's diet correlates with profit. This graph has percent pasture in the diet on the horizontal axis and return on capital or profit on the vertical axis. This confirms that percent pasture in the diet could explain 8% of the variation in profit. The relationship can be described as one, whereas pasture as a percent of the cow's diet decreases, there was initially little variation or impact on profit, although a negative impact becomes increasingly evident as the percentage of pasture decreases. In addition, percent pasture in the diet has a substantial impact on a wider group of ratios that are correlated with profit. Just look at all the important profit-related ratios in this table that are significantly impacted by the percent of pasture in the diet. They include cost of production, pasture, supplement, and total feed cost, and a wide range of core per cow and per hectare costs. You can also see at the bottom of the table that decreasing pasture as a percent of the diet decreases pasture harvest. In the next line up, you will see that it also increases labour cost. An interesting aspect of pasture as a percent of the cow's diet is that it does significantly correlate with lower labour cost. As was reported in one of my 2020 papers, the most relevant ratio for monitoring labour in a dairy business is labour cost per cow. This graph has percent pasture in the diet on the horizontal axis and labour cost per cow on the vertical axis. This confirms that percent pasture in the diet could explain 8% of the variation in labour cost per cow. So now you have pasture as a percent of the cow's diet significantly influencing the two largest cost areas in a dairy business, feed and labour costs, which comprise 70 to 80% of all costs. Though, as you saw in the previous table, it also influences other core, cow and hectare costs that, when combined with feed and labour, comprise well over 90% of all costs. Pasture harvest is quite similar in that it too influences most cost areas in a dairy business, including labour cost. This graph has pasture harvest per hectare on the horizontal axis and labour cost per cow on the vertical axis. This confirms that pasture harvest could explain 9% of the variation in labour cost per cow. This final graph is intended to highlight in simple terms the state of the Australian dairy industry. The columns are the cost of production per kilogram milk solids for each Australian region, plus New Zealand and the US, and the dots are the milk price per kilogram. Cost of production in this instance is calculated by deducting all non-milk revenue, such as livestock revenue, from total operating expenses. So this can then be directly compared to milk price. As a result, the gap between the dot and the top of the column is the profit margin, or profit per kilogram of milk solids. There is quite rightly a lot of talk these days about building more resilient dairy businesses. Well, these could be identified by having a comparatively low cost of production so that they are competitive both domestically and internationally, and having a high profit margin so that they can more readily withstand volatility in milk price, supplement price, and climate. Now I've added total feed cost per kilogram as a dashed line. You can see that a country like New Zealand and regions like Tasmania and Gippsland that have a higher percent of pasture in the diet, a lower cost of feed, a lower cost of production, and a higher profit margin are in the strongest position to maintain profitability and international competitiveness. Unfortunately, the majority of the Australian industry now has too high a cost of feed and cost of production to be consistently profitable and competitive, including Victoria as a whole and Australia on average. And finally, you have states like New South Wales and Queensland that, despite being paid a higher milk price than the US and most other countries in the world, have such a high cost of feed and cost of production that it is difficult to see how the average farmer in these states can be consistently profitable unless either their governments offer permanent subsidies or there is a reversal in the trend by farmers towards higher and higher levels of supplementation. So in summary, a change in production system to higher levels of pasture in the diet provides the only substantial option for improving profit in Australian dairy. Although comparatively high levels of pasture harvest are important, equally a high percent of pasture in the diet is important to deliver a lower average cost of feed. The reduction in percent pasture in the diet on Australian farms over the last 20 to 25 years has been the reason for this industry's loss in profitability. If this is reversed, then profitability can be recovered, along with international competitiveness and domestic comparative advantage against other land uses like beef production. There are a couple of major challenges in changing production systems, including managing the transition and breeding the type of cow that will thrive on a high pasture diet. But the prize of a stable, profitable dairy industry should make this worthwhile. Thank you.